United States Air Force just launched the U-2 Dragon Lady again. Headlines say, into space. But what does that really mean? No rockets, no astronauts, no orbit. And yet, the U-2 flies so high that the sky turns black. At over 70,000 feet, it operates in an environment closer to space than to normal aviation. Today, we're breaking down how the U-2 reaches the edge of space, why it still matters in 2026, and what secret missions actually mean. Because the Dragon Lady is far more advanced than most people realize. Let's be precise. Space is officially defined at 100 kilometers, the Kármán line. The U-2 does not reach that, but it routinely flies above 70,000 feet. That's over 21 kilometers high. At that altitude, the sky appears dark blue, nearly black. The curvature of Earth becomes visible. Air density drops to about 7% of sea level. Commercial airliners fly at 35,000 feet. The U-2 flies double that. It operates in a zone pilots call the coffin corner, where stall speed and overspeed margin are separated by just a few knots. Too slow, you fall. Too fast, you overspeed the airframe. There is almost no margin for error. That's not space, but it's as close as a jet aircraft can survive. The U-2 first flew in 1955. So, why hasn't it been retired? Because altitude equals perspective. From 70,000 plus feet, the U-2 can see deeper into denied territory, operate above most air defenses, carry heavier sensor payloads than satellites. Satellites have predictable orbits. The U-2 does not. That unpredictability is critical. If intelligence agencies need immediate surveillance over a developing crisis, they can launch a U-2 within hours, not wait for orbital timing. It becomes a flexible, airborne intelligence satellite. Let's separate myth from reality. The U-2 is not flying to Mars. It is conducting signals intelligence, SIGINT, electronic surveillance, battlefield mapping, missile launch, monitoring, high-resolution optical imaging. In modern conflicts, it has supported Indo-Pacific monitoring, Arctic surveillance, Middle East ISR operations. Its updated sensor packages include advanced radar and multispectral imaging systems capable of detecting camouflaged equipment, underground facility signatures, electronic emissions. The secret part is not the altitude, it's the payload. What the sensors can collect is far more sensitive than how high it flies. Flying the U-2 is closer to astronaut training than fighter pilot training. Pilots wear full pressure suits similar to NASA astronauts. Why? Because at 70,000 feet, cabin decompression equals instant unconsciousness. The suit provides oxygen supply, pressure regulation, thermal protection. The cockpit is cramped. Long missions can exceed 9 to 12 hours. And landing, it's notoriously difficult. The aircraft has bicycle landing gear. It requires a chase car on the runway to guide the pilot during touchdown. Even after decades, it remains one of the hardest aircraft in the Air Force to fly. The U-2 was once thought untouchable, until 1960 when a Soviet SAM shot one down. That changed strategy forever. Today, the U-2 doesn't rely purely on altitude. It relies on standoff distances, electronic warfare support operating outside modern SAM envelopes. It does not penetrate advanced airspace the way stealth aircraft do. Instead, it observes from the edge. And, because it flies so high, its sensor horizon is massive. It can monitor huge areas without crossing borders. Good question. Why not replace it with RQ-4, Global Hawk satellites, stealth drones? The answer is payload flexibility and human decision-making. The U-2 can swap sensor packages rapidly, adapt mission objectives mid-flight, process intelligence on board in real time. A human pilot can adjust instantly to unexpected developments. Satellites cannot improvise. And high-altitude drones still lack some of the Dragon Lady's payload advantages. That's why retirement keeps getting delayed, because nothing fully replaces it yet. No, but here's why headlines say that. At 70,000 plus feet, atmospheric drag is minimal, the sky turns dark. You are above 95% of Earth's atmosphere. To civilians, that looks like space. To aerospace engineers, it's the stratosphere. Still, it is one of the highest sustained operational flight envelopes of any aircraft in active service. It doesn't go to space, but it operates at the threshold. Eventually, yes. Candidates include advanced stealth ISR drones, high-altitude long-endurance platforms, possibly hypersonic reconnaissance aircraft. But here's the reality. The U-2 remains operational because it still delivers value. In an era of satellite warfare and anti-space capabilities, having an aircraft-based intelligence option is strategic insurance. If satellites are jammed or destroyed, the Dragon Lady can still fly, and sometimes redundancy is power. The U-2 does not fly into space, but it flies higher than almost anything else in military aviation. It operates at the edge of the atmosphere. It carries some of the most advanced sensors ever built, and in 2026, it remains one of America's most flexible intelligence assets. In modern warfare, dominance isn't just about speed or stealth. It's about vision, and at 70,000 feet, the Dragon Lady sees everything.